Let's make prediction using the line of best fit. So first of all, most data is not perfectly linear. So we have to use a line of best fit. We kind of create a line through the data so that we can use that line to make predictions. Okay, so first we have to talk about some pieces here. Correlation coefficient, known as the variable R. The closer R is to either -1 or +1, the more linear the data. And the more linear the data, the better the prediction. Now, interpolation means we're making a prediction within the observed range of X values. So that means we're like inside the data that we have, whereas extrapolation means we are making a prediction outside. Generally, the extrapolation is less accurate, not always, but because we're outside of the range, we don't know what happens out there, so it's harder to kind of guesstimate, I guess you could say. Okay, so let's look at this. Using technology, you find that the line of best fit for 10 to 25 minutes of strenuous exercise versus calorie burned is y equals 4.21x plus 3.29. Predict the number of calories burned in 18 minutes of strenuous exercise. Okay, so in this case, we're talking about x is minutes exercised, and y equals calories burned, okay? So we can go ahead and say, okay, if I strenuously exercised for 18 minutes, so I would say y equals 4.21 times 18 plus 3.29. Okay, order of operations. I'm going to multiply first. So 4.21 times 18 naturally is 75.78, and then I add my 3.29. So when I add these together, I end up with 79.07 calories. So, right, we're estimating. If I know that this is true based off of data, right, data that I had, if I strenuously exercise for 18 minutes, I will burn roughly 79 calories. Now, 18 minutes falls between 10 and 25, so this is an example of interpolation because it's inside the range of values that we have. Now, let's look at the next one. Let's predict the number of calories burned in 35 minutes. Remember, the range of data was 10 to 25. So 35 is extrapolation because it is outside the value that we have. But let's go ahead and plug it in. So y equals 4.21 times 35 plus 3 and 29/100ths. I'm going to multiply 4 times 35. 147.35, add the 3.29 to it, and if I exercise strenuously for 35 minutes, I should burn roughly 150.64 calories. Remember, this is strenuous. This isn't like go hard for 2 seconds and then relax. No, this is strenuous for 35 minutes. Based on my data, I should burn about 150 calories. All right, I can do that. Let's do one more. How long would you need to work out strenuously to burn 250 calories? Round to the nearest hundredth. Okay, so maybe this is your goal. I want to burn 250 calories, and I want to do it working out strenuously. Oh, this sounds fabulous. Okay, so 250 calories is our Y value. So I plug that in. 250 equals 4.21x plus 3 and 29/100ths. Okay, so let's not forget our rules of solving the equation. We need to get the variable by itself, so I'm going to move the constant over to the left first. My 3.29s will cancel out, and I am left with 246.71 equals 4.21 times x. To get x by itself, because the coefficient is touching the variable, that means multiplication. So I'm going to do the opposite, which is divide both sides by 4.21, and x is going to equal 58.60095. Beep, beep, beep. Keeps going on and on and on. Directions say round to the nearest hundredth. So that's 2 places. The next spot is a 0. So we would say 58.60 minutes. So just over 58.5 minutes will get me to that 250 calories, and that is working out strenuously. I don't know if that's really so good for you, but I am not an athletic trainer. At any rate, you can use lines of best fit to make predictions for all sorts of things.